Hey everybody, it's Erik, co-founder, partner of Village Global, a network-driven venture firm. And this is Venture Stories, a podcast covering topics relating to tech and business with world-leading experts. Hey everybody, welcome to another episode of Village Global's Venture Stories. I'm here today joined by a very special guest, portfolio CEO and longtime friend, Tyler Hayes. Tyler, welcome to the podcast.
Hey, it's good to see you, man. It's good to hear your voice again. It's been a little while.
Yes. So Tyler, you are the CEO of Atom Limbs. Why don't you describe what is Atom Limbs, and then let's get into the story of how you came to start it, because it's a pretty interesting journey.
Yeah, Atom Limbs is mind-controlled bionic arms, and it's real. Yeah, it's absolutely real, right? It's the first question we always get. Yes, it's real. We make what you see in movies like Blade Runner or Ghost in the Shell or video games like Deus Ex. We make bionic arms you can control with your mind, with your nervous system, and they're just as strong and as fast as the human arm. And then we sell them to amputees and quadriplegics, or we will in a year or two.
Yeah. So before we get into how it works, how did you come to start Atom Limbs? Why don't you share the journey behind it?
It's been a long journey. There's the short journey, which is when I saw this technology a couple of years ago, and there's the long journey, which is why would I even do something like this crazy in the first place? The short journey is the applied physics lab at Johns Hopkins had invented this arm over the last 10 years, and they had taken in $100 million of funding from DARPA. DARPA said, hey, you guys need to go make a lifelike robotic arm for war fighters who are coming back from war who've lost their arms. Needs to be as strong as a human arm, as fast, as light, as intuitive. And then a few years ago, Johns Hopkins put out some videos of this crazy technology. And I saw these videos. And so I just cold called them one day and said, hey, I'm really interested in this space. I advise, companies in this space. I invest in companies in this space. Can I get involved somehow? And at the time, we were running Bebo, our previous company. And I honestly wasn't even thinking about necessarily taking something like this to market. But then when we sold Bebo to Amazon, I basically decided not to go to Amazon and Twitch, and silently started a company to help Johns Hopkins bring this arm to market with our own vision of, this should be a no compromises, luxurious, premium product that can truly finally do what a human arm can.
And so, to zoom out, why couldn't this have been done 5 years ago? What was sort of the technical innovation?
Yeah, I think anyone who knows anything about robotics would immediately know, like, it's crazy hard, right? Basically, stuffing tons of actuators and gearboxes inside of a hand is so difficult. The amount of friction and power required to do that was blocking it for all of human history up until basically 5 or 10 years ago. We couldn't literally fit 15 or 20 actuators inside the size of a human hand and power them and not have it break. And so, basically $100 million from the government, that's what that buys you. You finally make that breakthrough. Pairing that with the advances in machine learning, also, that's what really makes this possible, right? So, how do you even control this thing in the first place? Well, it's not like you're going to be using pulleys to pull the thing, moving your shoulder back and forth or something like that. You're not going to be moving it with your other arm. You need to control it intuitively. And so, robotics was really, kind of in the dark ages until about 5 or 10 years ago in terms of human scale dexterity, and machine learning and neural networks were really early. And the advances in those have been insane. So now we're finally to a place where, we can listen to your nervous system, we can pattern map off of it, and we can predict, all right, here's what you're trying to do. And we can move a robotic hand as intuitively as you move your own hand, which I know it sounds crazy, but it legitimately does. We have finally got to that point.
Yeah. And so, zooming out for a sec, one of your goals was to help humans live forever, and it remains that. How did you sort of identify that this was the path to go down to help achieve that goal?
Well, yeah, I think that's one of the first things, you and I ever really jammed on was like, look, I want to cure death. That's what I call it. I don't even necessarily want to live forever, though I do. I want to cure death. It's like offensive to me that death is still a concept. So to me, how do you do that? Well, if the goal up top, if you're at like a whiteboard and you write, let's cure death, and then you circle that, and then you start branching off from that and say, well, how do we do that? There's two paths. One is reverse engineer the brain. The other is reverse engineer the body. And reverse engineering the brain is incredibly difficult. I know this because I studied neuroscience in undergrad. I wanted to be a neurosurgeon and became an entrepreneur instead. And we all just know this at this point. Like, you can talk to any neuroscientist and they'll tell you we are really still nowhere near truly understanding the depth and breadth of the human brain. We're making progress, we're not there. So I basically crossed off reverse engineer the brain and said, okay, let's reverse engineer the body. And then I literally just made a laundry list of all the projects that were tackling that and started talking to founders that were doing them and started trying to make them myself. And this was the one that arose to the top of the stack. And the reason why is because the technology is close enough. The market absolutely wants this. I mean, I don't think most people know this, but amputees are still really living in the dark ages. And the ability to bring the cost down is finally there. And I remember one of the first things you and I ever chatted about was like, all right, so how much does this thing cost, right? Are we going to the moon or are we like making a Tesla here? What's the difference? And it's much closer to making a Tesla than it is going to the moon. You know, you don't have to spend $10 million making one of these arms. You can get it down to, you know, in the thousands and tens of thousands of dollars to make these things. It's hard, but you can do it. So all those things together kind of, you know, pointed this, if you squinted just hard enough, you could squint and look 5 or 10 years out and say, okay, this is definitely going to be a thing. So how do we find the thing that's going to be able to do it? And it turns out, you know, it's the arm that we have.
Yeah. And so talk a little bit about the journey from Johns Hopkins to turning into a company and some of the lessons learned therein, because doing that just seems massively difficult.
Yeah, it is. It definitely is. It's called a tech transfer process. And so if you ever want to get technology that has been researched by an institution like Johns Hopkins or Berkeley or Stanford, if they invent something and you want to commercialize it, you go to their tech transfer department and you say, hey, I want to do this. Let's work together. And what I've basically learned is I call it like the third quarter lull. So like you play basketball and you know about this. It's like, when's the 2 highest energy points in a basketball game? It's the first quarter and it's the fourth quarter. And you have this problem with like the third quarter lull, you know, where it's like, all right, like it's like you're either down or you're up and you're barely up and you're trying to get through. And then the fourth quarter, you're like, all right, I can see the finish line. It's right there. And you start pushing harder again. Tech transfer is basically permanently a third quarter lull. It's just like everyone that you're working with, it's their job. There's a lot of bureaucracy. They have multiple departments you have to work with. There's a lot of, you know, signing documents and conversations and all this kind of stuff. But ultimately what matters is this. What we've learned is if you share the same crazy, it will all work out. And the crazy that Hopkins had was we need to make a lifelike arm. And the crazy that we had at Adam Limbs was we want to solve permanent injury and we want to cure death. And so, of course, this arm is a natural extension of that, basically. And so, you know, just to be clear, what we've done with them basically initially is, you know, we've executed an option agreement with them inside of this tech transfer process. And that gives you the ability to negotiate a full license. And this gets into, you know, the hairiness of tech transfer processes and optioning and licensing and all that. And it, you know, you should expect that it's kind of like raising a VC round, but twice as long and twice as hard. So you're going to spend a lot of time going back and forth. You're going to spend a lot of time getting buy-in from people. And you may or may not still get like a term sheet at the end of that. Versus if you share the same crazy, it's all going to be smooth the whole way. You're just going through the motions.
Yeah. And talk a little bit about how venture capitalists have viewed, it's one, you know, there's a perspective of how they viewed hardware, but then also how they viewed medical devices, and how much do you think of this is, you know, founded versus unfounded, or talk a little bit about how venture capitalists have viewed the broader space or adjacent spaces.
You know, I don't think it's a secret that venture capitalists tend to kind of be a little crazy, like on the edge of what most people would think could be possible. And that's their job. That's literally in the job description. So going to a venture capitalist office and saying, hey, we want to make mind controlled arms, like they're very receptive to that, right? It's not it's not a hard pitch. It's also not a hard pitch in general to say we want to make mind controlled bionic arms. The benefit and the curse of having really incredible technology like a mind controlled bionic arm or a supersonic jet or a nuclear reactor technology is there's always going to be the question of how long does this take and how hard is this really? And that's just the central nut of it. You know, this is the actual edge. This is the emerging tech edge of where things are. And so I think we're very fortunate to have found folks like you and everyone at Village, who look and say, yeah, we agree that future is coming. So how can we just set up for that future as best as possible? And that it really involves coming down to like, you got to get the right team in place as always. And it isn't like if you're asking about VC, this isn't like making a SaaS business where it's like, let's get, some really good people who are good at growth and like really good at quick product market fit. It's like, there's no question that the market wants this. We need to still deliver them the right product orientation and center around that. But it's way more around the right team, the right supply chain, the right logistics, the right execution, the right methodologies, the right soft equipment and tooling, and getting through prototyping as quickly as possible. And it's very different, I think, than what most venture capitalists are used to. And so there's this really kind of small but cool group of folks in the VC industry who are, those deep tech, emerging tech folks, who this is literally what they're looking for. And sort of like when Tesla had started, they basically were very fortunate. The guys at AC Propulsion found Elon Musk, who was basically willing to take the bet on them and say, you're the right kind of crazy. I share this kind of crazy. And it's really the same with mind-controlled arms. You can imagine that future, but the question ultimately comes down to the team.
Yeah, totally. What's the state of government funding for projects like this, or just any sort of insights into government funding opportunities more generally?
Yeah, I wish it was as good as it was 15 years ago. So the DARPA challenge for this arm started in 2005, and it was called Revolutionizing Prosthetics 2009. They thought they would be done in 4 years. Wow. And obviously you and I are having this conversation 15 years later, not 4 years later. And back then, the trend in government was just after the dot-com burst. So it was like, what were people paying attention to back then? It was software businesses for sure, but it was also robotics. It was the early days of social networks and commercializing, like better touchscreen technology. It was a lot of like hardware tech. Now, where the state of government funding is where the trends are now. They're very focused on AI, neural networks, drones to some degree, and it's really moved away from a lot of this robotic stuff. So that's like on the DoD, DARPA side. SBIR and STTR government funding is still out there, and it's phenomenal. I think if you go and you look at any kind of Bionics company, or you look at robotics companies, they pretty much all take probably some form of government grant in the form of SBIR or STTR. So it's still there. I do wish that the government had the appetite that they used to for this stuff, but it's just changing with the tides. And it's unfortunate because, look around, right? Like, we can go to the moon, we can go to Mars, we can send rockets, we can land reusable rockets, we have electric cars, we have war machines that cost millions of dollars, and we can't build an arm or a leg or an exoskeleton. Like, the technology is there. It is not a matter of technology. It is a matter of will. And the government has definitely moved away from that a little bit. So I think kind of comes down to the tech industry at this point to continue carrying that torch forward.
Yeah. And what changed? I mean, 15 years is not that long of a time for sort of, an institution to just sort of utterly decay. What's happened?
Part of it's the people.
Yeah.
Yeah. So you get the changing of the guard. And to be clear, I don't mean like the Trump administration or the Obama administration there. I mean literally in the weeds of DoD and stuff like that. So part of it's that. Part of it is also kind of like the VC industry. Where are the trends? Just where can the money go most easily? So from an objective perspective, if you just pour $1 billion in the top of some big funnel, where is it, like a pachinko machine, naturally going to kind of land? And it's going to trend towards the areas where people are kind of just think are hotter or more people are focusing on. And robotics went through this phase of companies like Intuitive Surgical that made the Da Vinci surgical robot, or Universal Robotics. Versus if you look at robotics now, for example, you see a lot of companies like, working on the AI side of robotics, Vicarious, Covariant, some of these kind of companies, and trying to enable robotics from that perspective. Versus, we really still need a lot of investment on the hardware side. That's the hardest part, right? Again, if you want to make something like this, you need to focus on the hardware as much as possible. Use software too, but really the hardware.
Yeah. And say more about that. Like, what does it mean to really, really get that correct, or what are common mistakes that people should really watch out for?
Well, yeah. I mean, I think to a non-roboticist, the way I would describe it is like, think of what you do with your hand right now. So I don't think listeners can see this, obviously, but like you're playing with your hair, I'm touching my face. We use our hands to communicate, we touch things, and it's just these fine movements, That's really, really hard to recreate. So there's this really damning statistic in the prosthetics industry that no one knows. If you look at leg amputees versus arm amputees, 4 out of 5 leg amputees use a prosthetic. So 80%, most of them use a prosthetic. But arm amputees, only 1 out of 5 use a prosthetic, only 20%. That's really bad. And the answer to why is really simple. It's because the hand. To make a prosthetic leg is like, no offense, but to people who've done it, but like it's pretty easy, right? You're making like a piston with a couple of joints on it. Now it's obviously more difficult than that, but that versus the complexity of the human hand, which has 26 degrees of freedom, which has all this sensory capability and feedback. You touch things, you feel heat, you feel cold, you use it to touch doorknobs, you use it to pick up plates, use it to communicate, to touch skin, to touch your hair. That's really, really complex. And to jam all of that into a small space the size of a human hand is really hard. So like, here's like one example statistic that makes this very real for people, besides the 1 out of 5 adoption statistic. It's like, if I asked you how many sensors you think are in the human hand, what would you guess? Like on a number scale, like 1 sensor, 100 sensor, million sensors, 100 million sensors, how many do you think are in the human hand?
I have no idea. I'm just going to go with 1 million.
Okay. So it's a good guess. That's a really good guess. That's probably what I would have guessed before I knew anything. It's about 10,000.
Okay.
There's about 10,000 sensors in the human hand. And prosthetic or robotic hands today have about 1 to 2 sensors.
Wow.
It's really bad. Ours has about 200 sensors. So it's 2 orders of magnitude higher than anything else, which is what allows us to do things like tactile feedback. So we can, you can feel things finally for the first time. But it's also still 2 orders of magnitude away from the human hand. So there's still a long journey to go.
Let's get into commercialization. Like, how do we commercialize something like this? What are the biggest lessons you've learned on the process of commercialization more broadly for this type of product? Why don't you sort of tell that story a little bit and tell your lessons from it?
There's a lot to that. Just imagine, again, using kind of like the Tesla analogy, what did Tesla have to go through to commercialize? They had the initial prototype that AC Propulsion made. They had to improve that prototype. They had to make sure it was safe and secure. They had to add all sorts of shielding. They had to go through the standard hardware development phases of EVT and DVT. They had to ramp it up and take it to production. And that's just like a literal logistics or operations perspective. But the real challenges are like, can you make a prototype at scale? Can you truly make it a commercial product? So our arm, like, where was it versus where is it now? So about 20 people have used this prototype in clinical trials as part of Johns Hopkins clinical trials. And those range from anywhere from like a day or a week long where someone visits Johns Hopkins to Johnny Matheny took it home for a year. He did a year-long take-home study. And the point of that is to address and identify the challenges that you're asking about. So those challenges of the commercialization process look like, how can you make this thing environment proof? 1, dust proof, waterproof. 2, things like shielding. So EMI shielding. How can you make it safe so people can't hack it when you're walking through a Wi-Fi congested area or a Bluetooth congested area? Same as like when Vice President Dick Cheney had a pacemaker, there were real concerns that, people would try to hack his pacemaker. 3, there's the obvious, commercialization challenge of price. How cheap can we get this? Because ultimately we'll be selling it to insurance first, and everyone knows the beast that is insurance. And the commercialization process for all those things looks like a very typical hardware commercialization process, but it also looks very unknown. Our team is, full of ex-Apple, ex-Intel, ex-IDEO, ex-Intuitive Surgical folks who are really good at this stuff. But at the same time, this is the first time anyone's ever done this. So we're charting a lot of unknown territory here. And that's what excites us, to be honest, right? That's what's cool about this. You only get to invent the iPhone for the first time once. And you only get to invent the world's first mind-controlled bionic arm once. So that's what that generally looks like.
Yeah. before you guys, like what was the closest thing to what you're doing, or what has sort of been the market map look like for companies sort of in the even adjacent spaces, and how have things turned out?
As in like the history of all this kind of prosthetics and robotics and stuff.
Yeah.
Yeah. Up until about 20 years ago, it wasn't great. You would have called it like Civil War era technology. So if we're just talking about prosthetics and human scale robotics, and when I say human scale, I mean like the size of the human hand and able to do what the human hand and arm can. The history of that up until 20 years ago was you'd chop off someone's arm, you'd fold over the skin, and then you would attach a vacuum suction socket to them that could hold a prosthetic arm in place. And up until 20 years ago, arms were easy enough to control because you sort of only need to flex and extend your elbow and your wrist. But the hand, what do you do for the hand? How do you get individual finger control? And up until 20 years ago, it was basically really rudimentary. You would physically take your other non-amputated hand and you would adjust the fingers in the hand into place. And then 20 years ago was the myoelectric wave of innovation, where now we had electronics inside of these hands and you could physically flex your bicep or your tricep in two-site control to adjust the hand. So what that means is literally the way you would control prosthetics before is you would physically flex your bicep to move the elbow one way and physically flex your tricep to move the elbow the other way. And if you wanted to move the hand, there was no individual finger control. So then how do you move the fingers with electronics? Well, you'd press a button on the arm to move it from elbow mode to grip mode. And then as you flexed your bicep, it would go one direction through the grips, through like a key grip or a plate grip or a piece grip. And then you'd flex your tricep to go the other direction through those grips and just rotate through them. There's about 10 or 12 grips that all prosthetic hands had. What then has happened since then? Honestly, nothing. And it's really frustrating. And I'm the last person to get angry about stuff. I'm from the Midwest. I giggle a lot. Like I get excited about this stuff. It's just really frustrating. It's like almost insulting. Like, why hasn't this progressed more? And again, the technology is there and there is money. So it's a matter of will. And when you look at these incumbents who are making these products, they are largely billion-dollar companies that are very happy to sit and not innovate. And they basically only innovate through acquiring startups. And so for the last 20 years, since that electric wave of innovation, nothing has really happened. And that's why what we're doing is such a leap forward. And it's like, I don't want to be saying that, right? I would love if this problem was already solved. I would love if there was a steady drip of innovation of this stuff. But frankly, there isn't. It's basically start, stop every couple decades. And we dramatically need to stop that. I furiously believe that we need people who are pushing this stuff forward all day, every day. That's the only way we're going to get there. I mean, I think it was MLK who said, he was like, progress is the grand arc of history. And that is true, but it is only true if humans are pushing it forward. And if you don't, we have way too many examples over the course of history where these things don't get pushed forward. And it's not just in technology. It's in areas like civil rights. It's in areas like human rights. And it's the same in technology. It's just not going to happen unless we're pushing it forward. And that's literally what we're trying to do right now. It's not more complicated than that.
Yeah. And what are the biggest bottlenecks in your view? It may be any ones that we haven't yet covered in terms of what's making it so hard or preventing the type of innovation, but besides sort of the desire to want to do it. Like if you can anything about how the system works that would make things a lot easier, where do you think the leverage points are?
All the stuff we were talking about earlier. So it's things like those robotics advances. To be really frank, we've kind of already crossed those boundaries. So, if you'd asked me 5 years ago, it would have been those same things. It's how do you make human scale robotics and how do you get ML and neural networks to a place where it works and intuitively. We've crossed those boundaries now. So now it's a question not of can we do it? It's a question of let's just make it cheaper. Let's make it better. Let's make it faster. Yeah.
Totally. So, one thing we haven't yet gotten into yet is how the thing works. Why don't you talk, just tell a little bit about sort of, let's look behind the curtains.
Okay, fair enough. So what we say is it's a mind-controlled bionic arm. So what's the first question everyone asks? It's the first question you ever asked me, which is how? Like literally how? How is this thing mind-controlled? Do you put a cap on someone's head? Do you put an implant in their brain? If you're a neuroscientist, you ask questions like, is it a Utah array? Do you use peripheral nerve implants?
Yeah.
That's my neuroscientist voice. I've been working on it for years. It's actually pretty straightforward. The way it works is we put a band, like a bracelet, around your arm, or if you're an amputee, we put it around your stump. And it's okay. You could say stump, by the way, like amputees. It's a term of, that everyone uses. But more commonly, you could just say residual limb. So we put a band around your residual limb above the point of amputation, and it uses surface EMG to listen to your nerve signals. So we don't put anything in your brain. We don't cut open your skull. We don't put a cap on your head. You actually have this band that can even sit under your shirt that no one will ever see. And it's EMG just like your doctor would use to listen to your signals. And when you think, the signal from your brain travels along the nerve, down your spinal cord, out your arm, and then the band hears it. And then the band sends that signal wirelessly over the robotic arm. It's real time. And then the arm uses machine learning and AI to move intuitively just as you intended to. And again, it's all real time. And it happens, sub-millisecond. So just like you move your arm, an amputee or a quadriplegic can move this arm just by thinking. So that's what we mean by mind control. It's not mind reading, but it is mind controlled because it is still using your neural system.
How do you expect this to change in the next decade or so as sort of brain-computer interface technology improves?
Yeah, I'm so excited for that. If you use this Tesla analogy again, Tesla had the Roadster, and then they had the Model S and the Model 3. I don't think most people even really remember this, but Tesla only sold about 2,000 Roadsters. It wasn't that many. And the point was to prove the concept and prove it can work. You can make a sexy electric car. With our arm, this is our Roadster. And it's to prove that you can really do this. But there's so much more. There's so much more we could do. So what are the things we can do now that can be leveled up? Like if you have a progress bar on each of them, like 0 to 10 or 1 to 10. So, finger dexterity right now versus a human hand, let's call it like an 8 out of 10 or a 9 out of 10, right? It's pretty damn good. Johnny played Amazing Grace on a piano with the arm. There's a video of it. We'll release at some point of that. It's incredible. In terms of tactile feedback from your environment, touching things, feeling heat, feeling surfaces. We're super early days on that. And I'm so excited to see what we can do next on that. There's also the speed of it, so how quickly can the thing respond to your environment without you actually doing something? And this starts to get into like the crazy sci-fi future stuff, but this is the kind of cool stuff that people really think about. So can you program the arm to cook eggs? Can you program the arm to play tennis? Can you program the arm to write letters for you? Now, we're not going to put like a murder mode in it. You can't program it to do stuff like that. But, there's zero reason why we wouldn't, allow people to do stuff like that. And I don't think that means necessarily something like an app store for an arm, but I do think it means the next level of the human body 2.0. If what we have right now is human body 1.0, what is human body 2.0? And it's going to be things like downloading things other people can do. It's going to be things like reacting to your environment when you can't. If you're walking down the street and you're about to run into something and you're looking the wrong direction, this is crazy, but an arm that has its own sensors in it can see that and can either move, without your intent, or it can alert you basically, with something like a haptic feedback that kind of buzzes you on the skin or something like that and tells you, hey, something's happening, like basically kind of a spidey sense. And I know that sounds crazy, but this stuff is actually not that far away and it is very real. And I think a lot of people think about the future of what the human body looks like, and they don't really have a good grasp on that, but it looks like kind of that commoditization of what a lot of humans do. So let me ask you a question. Like, if you could be stronger, would you want to be stronger? If you could be faster, would you want to be faster? If you could have your same body you have now when you're 60, would you want to have it when you're 60?
I just want to dunk, Tyler. Make arms, legs, help me dunk. Yes, of course.
All right, we'll put a dunk mode in, and we'll call it the Tornberg mode. Yeah,
exactly. I know it's going to take some time to help someone like me be able to dunk, but no, yes, obviously to all of your questions.
Yeah, and I think that's what everyone's answer would be, right?
Yeah.
And so, if that's the question, okay, well then the next question is, well, how do we do that? Okay,
right.
So just go invent those things and make that happen. Yeah.
So, and let's segue back to death, because it's so fascinating how culturally, of course, we want to cure cancer. Of course, we want to cure all sorts of diseases that, let people die, or enable people to die earlier. Yet, when we talk about curing the sort of the source of those diseases, or the root of those diseases, such that you're not extending your life 5 years or 10 years, but it's undetermined, then people get really uncomfortable for some reason. Why do you think we're so uncomfortable around the idea of curing death? Like, what's our attachment to death?
Mm-hmm. I mean, do you get uncomfortable talking about death?
I don't. Maybe it's because I've been around so many crazy people that I've been sort of cultured out of it. But there is some. I don't know if it's religious. I don't know what the trope is around, or the just real attachment to wanting to preserve death for everybody.
Yeah, death is like a unnecessary obligation to me. I find it honestly offensive that the universe has basically like imposed this arbitrary limit on us. And it is arbitrary, right? Like, other species live longer than us.
Yeah.
Why do we live this long? Okay. Well, it has to do with things like, at the biological level, we're an organism that takes a lot of energy to power. The brain that we have just requires a lot. And so over time, you sort of evolve to only live so long. And there's no like literal reason why it needs to only be that long. So the question I like to ask is, okay, if you could live 200 years instead of say 100 years, would you want to live 200 years? If you had all the same health and all the people you loved were still alive, like, would you want to live 200 years?
I would, yes.
Okay. I would too. And then the next question is, okay, well, would you want to live 500 years? And I would. I don't know if you would.
I would never want to prematurely, call my own death. Maybe at some point I'll be like, you know what, take me out. But I like having the option.
Same. Exactly that. I want the ability to choose when I die. And it's about freedom to choose. I can choose where I go to school for college. I can choose my job. I can choose what I eat. I can choose my romantic partners, my friends. I can choose where to live. I can't choose the single most important thing in my life, which is when and how I die. And that is just a crazy thing when you start from an objective perspective. So if you agree with that, then asking, well, do you want to live 200 years or 500 years or 1,000 years is the same thing. Most people, when I ask those questions, initially start to hesitate around 500 years. And the reason I've found that most people are super uncomfortable about that is because they basically don't understand what the future will look like. Like, they basically think, it's either going to be really bad, we're going to destroy ourselves with nukes, or they think it's just going to be kind of shitty in general, or they think that all their friends and family are going to die, or, and this one seems crazy to me, they can't imagine what they would do with the time.
Yeah.
And that's weird, right? Like, how can you not imagine what you would do with 500 years? To me, that's crazy. Like, I would be a film director for 100 years. I would be a sailor for 100 years. I would do nothing and meditate for 100 years,
Yeah. Yeah. There's just so much to do. Yeah. Where did your motivation from wanting to cure death stem from?
I basically just went through a lot of like trauma in my early life around this. And I actually don't know if you and I have ever really talked about this. So I'm 34 right now. When I was 24, my dad died from lung cancer. And it was like, it was really tough. And it was tough because he didn't handle it well. He didn't communicate about it well. And, I don't want to go into super great detail about that to respect his privacy post-mortem, but, it just wasn't handled great. When death isn't communicated great up front, it's definitely not going to be handled great after the fact. And, he said a couple things to me when he was in the hospital, a couple days before he died, he was just kind of like, you got to go find your way and all these kinds of things. And I was at the time, sort of aimless. So I was living in Minnesota. I wasn't living in San Francisco. I was like running this PC repair business, which was fine, sort of a Geek Squad competitor. It was going fine. But like, I was really content to not do a lot. And honestly, when he died, it just kind of shocked me out of complacency. And like literally, 2 months later, not even 2 months, I sold everything I owned. I sold my car. I sold all my belongings. I sold my girlfriend. I sold everything. And I moved out to San Francisco. I bought a one-way ticket. I took 2 suitcases and I moved to San Francisco. And I just said, I want to be a part of something better and greater. And I want to improve the world. And this is crazy. And back then, honestly, I didn't have a super well-formed thought around like living forever and how to attack that, even though that is my life goal now. Like my one life goal is to cure death. I have a second life goal, which is to be the first human being alive in another solar system. But that comes after. But it was just really, really hard. And what I took away from all that is life is just like absurdly short. Like it's painfully short. And to the point where I even did the math and I was like, how much time do I actually have? And it was really eye-opening for me. So basically what I learned is from the moment you turn 30, you have almost exactly 10,000 waking days left in your life on average.
Wow.
And so when you turn 30, the next day, that clock ticks over from 5 digits to 4 digits. It goes from 10,000 to 9999.
Wow.
And when I say waking day, I mean, you're awake for 16 hours, so pull 8 hours to the next day. But 10,000, that makes it very real, right? Every day really matters. It's not a million. It's not a billion. And not only that, but like I shouldn't say I could die at any point. I bike to work. I've been hit by cars. I used to skydive. I stopped skydiving, just like unnecessary risk. And it's permanent, unless you kind of get into the religion of it. And, I don't for personal reasons, but like, if you don't believe that there is an afterlife, it's done. And so for me, it's like, I think I have sort of a different internalization of this than most people, where it's just like this really acute problem. Like literally when I wake up and literally when I go to sleep, I think about this stuff and I feel that really acute sense of how short life is. And so what do I want to do with my time? Look, I would love to go do really fun things that have nothing to do with pushing the human race forward. And I do, right? I have hobbies. I go surfing and I hang out with friends, but that's not the majority of my time. And I think to anyone I've ever talked to about this, they usually kind of adopt something like this, because once you realize how short it is, you want to do something that's meaningful. And I have no problems with people making photo sharing apps and social networks. That's not what I'm getting at here. But meaningful, fundamental problems don't get solved unless people work on them. And so for me, when I figured, fuck it, like I got 50 years at max, unless we have some breakthrough on anti-aging. So we need to start this now.
Yeah.
And that's why I do what I do.
Yeah. I think it's a great place to wrap on the note that that life is short. For people out there who are fascinated by what you're doing and want to go deeper as they should, what can you point them to? Or any upcoming plugs or things that people should watch out for?
Yeah, absolutely. First of all, the first thing they should do is they should go follow me on Twitter and they should follow Adam Limbs on Twitter. I'm very outspoken about it. I love talking about this stuff. I think if people share this kind of crazy about like bionics and robotics and cyberpunk future and all that kind of stuff and helping people get their limbs back, then like tell me, let's jam about it. There is always room for more people on our team or more people to help us. And if someone's an amputee or a quadriplegic, they should absolutely sign up for our waiting list, which is on adamlimbs.com. If someone's just interested in the space, they should follow our Twitter account and they should join our Facebook group where we basically share all these things and we constantly share what we're doing. We are very unlike most other companies. We build in public. So basically starting from this week, when we start talking about this, we're building in public and we want everyone who gets riled up about this stuff, who shares that crazy, to come along this journey with us. And I can't talk too much about some other things we've got going on in the next couple of months, but definitely stay tuned. There are some very, very big announcements we'll be making on all fronts. And I'm really excited to reveal some of these things that are on the product front and some of the other fronts that I think are just going to blow people's minds about what's coming.
Awesome. Well, Tyler, it's an honor to be a supporter of your mission. This has been a great episode. Thank you so much for coming on.
Yeah, thanks for hosting. Absolutely.
If you're an early stage entrepreneur, we'd love to hear from you. Check us out at villageglobal.vc.